Okay, in this section we're going to be talking about total resistance. So that's going to be the idea. So circuits, any circuit technically, can be reduced to more simple circuits by using the concept of total resistance. Total resistance. Yes. So you could do that for both circuits in series and parallel. We're going to be looking at series circuits first. So the total resistance in a series circuit can be found using this formula right here. So the total resistance equals R1 plus R2 plus, if you had more resistors, you just keep adding them. So if you had R3, you just add R3 plus R4. Right? You can continue with this. That's what the dot 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 means. So that would be the total resistance. So what that means is if you have a circuit, you have multiple resistors in series, like this. What you can do is you can simplify this to basically a simpler and easier circuit. So again, that's the idea with total resistance. You could take a circuit, you break it into a more simple circuit that's mathematically equivalent. So again, this is the formula for series circuits right here. And it's important to note because you're basically adding all the circuits together. It's just a sum. The total resistance is greater than any one resistor for series circuits, because the resistance is getting greater and greater, you're getting more and more obstacles basically. Now, the same idea can be used for parallel circuits, so you can figure out the total resistance for parallel circuits using the following formula right here. 1 over R total is equal to 1 over R1 plus 1 over R2, and then if you had more circuits, you just keep adding them, or more resistors, you keep adding them. 1 over R3 plus 1 over R4, and so on. So that's what the dot 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 means there too. So again, same idea. If you had a parallel circuit, let's just say you had 2 resistors. Yep. You could, using this idea, you can simplify it to a simpler circuit with just 1 resistor, and this would be mathematically equivalent. So with the parallel circuits, it's important to note that this is actually a typo right here. This should be less than. So R total is less than any individual resistor for parallel circuits. So again, any one resistor is going to be greater than the total resistance. The idea being is in a parallel circuit, you're adding more paths. So if you keep adding more paths for electricity to flow, you're really bringing down the overall resistance. So that's the idea. And again, like I said a bunch of times, a simplified circuit is, you can replace all the resistors with just a single resistor. That's what I have drawn here and here. So that's the idea. It's taking a circuit, it's breaking the circuit down into something that's simpler, but still mathematically and conceptually equivalent. Okay, that's the idea behind total resistance. Now let's see a problem with this. Problem. Here we go. So here is the problem. Before I go through it, make sure you take an attempt at solving it. Okay, so I'll go through this. So it says calculate the total resistance and sketch the simplified circuit for the following. So A, we have two 8 ohm resistors and one 5 ohm resistor in series. So not a bad idea to just sketch out what this looks like, what the original circuit looks like. And it will look something like this. Two 8 ohm resistors. There we go. One 5 ohm resistor, and they're going to be in series. So what we have with this is we really want to figure out, okay, this is the original circuit. How do we simplify it or what's going to be the total resistance if we'd like it simplified. So the simplified circuit's going to look like this. Like I said before, it's just going to have one resistor. It's just going to have R total. But we just need to know what this value is for R total. So if we want to figure out the value for the total resistance, we just have to use the formula for series circuits. So it's just the sum of all the resistors. There's going to be 3 of them. R2 plus R3. So that's going to be equal to 8 plus 8 plus 5. It's going to be 21 ohms. So it's fairly straightforward for a series circuit. So the total resistance is just a sum of all of the resistors, basically. So in this case, this would be the simplified circuit. R total is equal to 21 ohms. So that's the idea. And if we notice, so this is our total resistance. It's just a sum of all the resistors. If we look at this, 21 ohms is greater than any individual resistor. It's greater than either of the 8s or the 5, because we keep, every resistor is going to add just another obstacle for electricity. So that's the idea for the series circuit. Now B, we're going to look at something very similar. So we have 2 8-ohm resistors and a 1 5-ohm resistor in parallel. So again, never a bad idea. Let's just sketch it out. Sketching. So we have 3 resistors. 1, 2, 3, and they're in parallel to each other. So we have an 8, we have an 8, we have a 5, and that's going to be equal to this equivalent circuit with just one resistor. So we're really looking for what our total is going to be. We don't know what that is, but much like the series circuit, we just calculate using the formula. So we have 1 over R total is equal to 1 over R1 is, there's 3 resistors plus 1 over R1 plus 1 over R2 plus 1 over R3, and that's going to be equal to 1 over 5 plus 1 over 5 plus 1 over 8, and that's going to equal, if we plug all this into a calculator, I mean you can simplify the fraction too, but you know, calculator's fine for this. So you can get 0.45. But that's not the answer in itself, because what we have right here is we have R total, well, our 1 over R total is equal to 0.45. So we're not looking for 1 over R total, we're looking for our total. So if we simplify this a little bit, if we do a little bit of algebra, we're going to get 1 over 0.45 is equal to R total. So you could do this to get from here to here. I'm just moving it around with algebra, or you could just take the inverse of both sides. They're the same idea. So our total is going to be 1 over 0.45, and that's going to be 2.22 repeating ohms. So that's the idea. That's what our total is. So this is the simplified circuit up here. So it's going to be 2.22 repeating ohms is the total resistance. So important to note with this, you see this, the total resistance is pretty low. It's 2 point something. So that's lower than any one of the resistances. That's lower than either of the 8s or the 5. And that's because as you're giving electricity more paths to flow, you're basically you're lowering the resistance. You're making electricity able to flow easier, basically. Okay, so that's the idea for both series and parallel circuits. You can get the resistance, or the total resistance. You can draw a simplified circuit. It's a similar idea, but as you can see, there's 2 different formulas. And just watch it when you're doing the parallel. Just make sure you're watching out that you're doing the formula correctly, that you're not stopping at just calculating 1 over each of the resistances. And that's about it for now.